Hi, my name is David Gabay, a computer engineering student. Today I'll be demonstrating a SQL injection exploit on a metasploitable VM running Mutilidae, a web application used to present or demonstrate vulnerabilities. First, I'll begin with the problem, describe SQL injection. Then I'll give you guys a demo, and I'll provide solutions and conclude. So OWASP, the Open Web Application Security Project, has named injection attacks as the #1 risk for web applications. And some of the other risks are broken authentication, sensitive data exposure, XML external entities, bad access control. But the important part is #1 risk is SQL injection. So what is an injection? Injection can result in data loss, corruption, or disclosure to unauthorized parties, loss of accountability, or denial of access. Injection can sometimes lead to complete host takeover. What this means is if a injection attack occurs, a malicious actor can gain sensitive data used to take over a host. And what is a SQL injection in particular? It's just the making of a malicious SQL query to a database in order to gain sensitive information. So in other words, it's bypassing, usually bypassing authentication and being able to query information that you shouldn't otherwise be able to query. So an example here is a visiting a website and impersonating an ID, but this time instead of putting an actual ID, we put or 1 equals 1. In this syntax, which is specific to SQL language, and 1 equals 1 will always work, so it will just show essentially this query will show all the IDs. So now I'll go into a demo. The way I am running 2 virtual machines. One is Kali Linux, and the other is Metasploitable 2, which is running the Mutilidae server. In order for these 2 virtual machines to communicate, it connects them to a host-only network adapter, and I'll demonstrate that right now.
Okay, so here are the VMs running in VirtualBox. The only changes, here's the Metasploitable. Go to network and have it on a host-only adapter. And the same for the Kali Linux. Make sure it's on that same host-only network adapter. And here I have them both running. This is the Metasploitable machine at IP address 192.168.1.623. And here I have the Kali Linux, and it is browsing at that same IP address as the Metasploitable machine, 192.168.1.623. And the Metasploitable machine is running a Mutilidae 2 web server, which hosts this web application. And this Mutilidae allows you to perform various web application attacks, such as injection, SQL injection, HTML injection, cross-site scripting, and more. Today I'll be demonstrating the SQL injection, how to extract data you shouldn't otherwise be able to extract, using a SQL command that alters the query, bypassing authentication. So without further ado, I already have it here, but I'm going to demonstrate again. So I already registered an account under David, and the password is password. So what this is supposed to do is show details for usernames with David and password. As you can see, this is already a weak website, as it allows multiple users with the same username and same password, and therefore I can see details for anyone who puts a username David and password. But now I'm going to show you how to get, using a SQL injection attack, how to get everyone's username and passwords. Uh, if we can break the system, we can see what the query looks like, and I'll do that by putting some invalid commands, hopefully. Yes. So right here, it kind of shows us that our query that's going on. So select all from accounts where username and then what we put in. So essentially we have to put a valid query language argument here rather than what we entered that will disregard this password and everything else. So to do this, I'm just gonna put, as you can see here, usernames begins with a quote, so we have to somehow end that quote. Then this dash dash is representative of a comment, so it comments the rest of the query out. So we'll be able to bypass the end password part. So let's try close the username argument and put an or statement that says either username is blank, or we can put 1 equals 1 or 2 equals 2, because these are both valid arguments, and the dash dash, which will close the rest. In a weak database, this should break. This is the definition of a SQL injection attack, and it should break the query statement and allow us to see everyone's records, the records of everyone on that database. We shouldn't need a password, so let's go ahead and try this one out. Failure, let me just, so close it, or let's just put a password here and see if that was the issue. Sorry for the confusion. It appears I had an extra space here, so we just put or 1 equals 1 dash dash, and I remove the space from between this quote and the or, and we go ahead and try that out. Oh, as we saw, it didn't work. It appears I was missing an extra space after the comment, so right here there was another space required. So if we just hit enter, we can see all the records in the database.
So in order to prevent a SQL injection, OWASP recommends using API which validates the input. So essentially check for input for invalid characters such as a single quote, double quotes, and other escape comment characters like the common character for SQL, which is a double dash. Another possible countermeasure is use a limit in the SQL controls with the queries to prevent mass disclosure of records in case of SQL injection. So as you saw, we can see all of the records in that database when we exploited it. if you put a limit that says max 2, then you would only be risking 2 records, which is still bad, but if you really want to do, maybe limit 1, and maximum casualties here are 1 record. Thank you for watching. Good luck.